Okay, today we're going to talk about the solar system. And my name is Weldon, and this is the instruction for the content that we're covering. First of all, the standards we are addressing, I pulled these from the Alabama State Standards. This is grade 4. And these are the 3 objectives that we're going to do today. We're going to talk about the solar system, identify major components of our solar system, including the sun, planet, and satellites. And then finally, we're going to compare the sun to a planet, to the other planets in our solar system. So when we talk about the scale of our solar system, the sheer vastness of it is very hard to comprehend. But if we thought of the sun as a grapefruit, for instance, like 10 centimeters in size, then the earth would be like a grain of sand, 1 millimeter in length. And if that grapefruit and that grain of sand were measured in distance, they would be 15 miles away in concept of how far the earth is away from the sun. Jupiter would be like 80 miles away, while Pluto would be 700 miles away. And the size of Jupiter would be 1.5 centimeters compared to the 10 centimeters of the sun. So when we talk about another concept, it's the 2 types of planets in our solar system. We have terrestrial, which is rocky with molten cores, and then we have Jovian. And these are mainly gas and liquid with rocky cores. The rocky planets, which are the core planets, which are the 4 that we have in the solar system closest to the sun, are the inner planets. And they have solid rock surfaces and an iron core. While the gas planets are predominantly larger planets, they have no solid surfaces, and they just gas and clouds, and they get denser as you move to their core or their center. The relative distribution of the 2 types of planet are like this. When you see this visual, it helps. The rocky planets are closer to the sun, while the gas planets are farther away from the sun. Relatively in size, though, gas planet worlds are much larger than the rocky worlds. Jupiter is by far the largest gas giant in our solar system. When we talk about the relative number of rings and moons, gas giant worlds have rings and many moons, while the rocky worlds have no rings and none or few moons. For instance, the Earth has 1, while the other ones have none, in terms of Mars, Venus, and Mercury. And this is a scale of the orbits as they travel around the sun. Each of the green lines dictate the shape. Some are more elliptical than others. Some are close to being round. All orbits are in the same direction and in the same plane, which suggests a common origin. While the solar system formed when a cloud of gas and dust in space was distributed, the gas and dust drawn together formed a solar nebula. This cloud began to spin as it collapsed, and therefore it flattened. As the disk got thinner, particles formed clumps, and eventually they formed the planets that we have today. Remember, why are there 2 types of planets? All right, inner planets are hotter than the outer planets. Only material that solidify at higher temperatures can condense to form the planets that we know today, while the other ones are more predicated by ice. We also have asteroids and comets in our solar system. They are leftovers from the process that we just discussed. Rocky asteroids inside are in the frost line. Icy comets outside are outside of that frost line. We talk about Mercury, right? The closest to the sun. It has the largest temperature extreme from 183 degrees negative Celsius to 430. It is the second densest planet after the Earth, so they must have a large iron core. It has a very thin atmosphere consisting of atoms blasted off its surface from solar winds. The atmosphere is constantly being replenished. When we discuss Venus, Venus is a similar size to the Earth. Its atmosphere is of carbon dioxide and nitrogen. It's very hot there due to the greenhouse effect. It gets up to 462 degrees Celsius. And of course, there's Earth. Earth is at a distance of 150 million kilometers from the sun. Sunlight takes 8 minutes to reach us. Our atmosphere is composed of 78% nitrogen, 21% oxygen, and 1% other constituents. 71% of the Earth's surface is covered by water. The Earth is the only planet in the solar system known to harbor life. When we discuss Mars, Mars is 1/10 the mass of Earth. The average temperature is negative 63 degrees. Rocks are made of silicates, like sand, and also a dash of iron oxides to give it that reddish color. Mars is rusty. The surface is dry now, but scientists believe there was once rivers, lakes, and maybe oceans of water. Mars has the highest volcano in the solar system, Olympus Mons, at 24 kilometers. It is 2.7 times taller than Everest, the tallest point on Earth. Remember, Jupiter is the gas giant. It's the largest planet in the solar system. It is 11 times the Earth's diameter. Jupiter takes 12 years to orbit the sun and rotates in about 10 hours. The red dot is a storm that's been raging for over 300 years and is twice the size of Earth. Uranus is primarily composed of rock and ice with only 15% hydrogen, much less than Jupiter and Saturn. No rock core like Jupiter and Saturn, but materials more evenly distributed. There are no liquid metal, hydrogen envelopes. And Neptune is composed of ice and rock with about 15 degrees helium as well. Atmosphere mainly of hydrogen and helium with a little methane, which gives it a blue color as methane absorbs red light. The small solid core is the size of the Earth. No distinct layers like Uranus, unlike Saturn and Jupiter. Now, what counts as a planet? Because Pluto was once considered one. The definition is it orbits around the sun, it has significant mass so that it is nearly round, and it has cleared the neighborhood around its orbit. So the ones that did not qualify for this are called dwarf planets. And there are several of these here. Pluto is the most famous one because it was identified as a traditional planet until 2006. So that is our discussion of the solar system and the main facts about it.